So my name is Jorgensen, and this is a project that I did in collaboration with Lise Jorgensen at my institute and Cecilie Meidel at the Norwegian Veterinary Institute and Knut Bø at the Norwegian University of Life Sciences. So, horses adjust well to low temperatures, and they set thick hair coats as winter approaches. Some horse owners find this very impractical and choose to clip their horses or use blankets. Blankets, however, impair the horse's own ability to adjust to changing weather factors. As an alternative to blankets, one could offer a shelter to the horse. And earlier research have shown that horses use man-made shelters to a limited degree, and feral horses seek shelter from the sun. They seek shelter for dry resting places and areas that give relief from insects. There are a lot of myths surrounding blankets and whether horses need extra protection in cold winter weather. Earlier studies on a few breeds in Nordic winter conditions show that horses can withstand really low temperatures, but they also seek shelter during precipitation and wind. So the aim of our experiment was to investigate the effects of different winter weather conditions on shelter-seeking behavior of horses and their preference for additional heat. From this, we came up with several hypotheses. The first saying that weather factors will affect the horse's use of shelter, and from this we predicted that horses would use the shelter more on days with precipitation. Another hypothesis rose from common talk and common practice on most riding schools and stables, namely that the horse's outdoor behavior would be dependent on breed. And from this we predicted that warm-blooded breeds would react to the cold before cold-blooded breeds, and that warm-blooded breeds would use the shelter more than cold-blooded breeds. I hope you agree. We were very lucky to borrow 17 privately owned adult horses. The horses were both mares and geldings, and their age ranged from 4 to 28 years. We divided horses into 5 different breed categories according to their height at the withers and their body characteristics. So we got one category for ponies, one category for small cold-blood horses, one for large cold-blood horses, one for small warm-blood horses, and one from large warm-blood horses. We also interviewed the horse owners to gather information on training and normal use of blankets. We measured their height, their weight, and their body condition. Hair coat samples were collected using an electric clipper from a 3 by 3 centimeter area on the horse's hindquarters. The hair samples were dried in a laboratory drying cabinet for 2 days at 50 degrees centigrade and then weighed. Sample weights ranged from 0 in clipped horses to 3.3 grams. And cold-blood horses had thicker hair coats with a higher sample weight than the warm-blood horses. And this is a picture showing the difference in samples and how it could look like. 2 identical experimental enclosures, each measuring 11 times 11 meters, were established using electrical fences in 2 heights. Inside enclosures, there was a shelter with 2 separate compartments, each measuring 3.7 times 3.6 meters. One of the compartments was heated, the other was not. 2 identical shelters with 2 compartments like this facilitated observations of 2 horses simultaneously. Horses in the experimental enclosure could not see each other, but they could see other horses in nearby paddocks. And this is how it looked like. A light was installed in each of the compartments together with an infrared heater. The infrared heater was turned on only in one of the compartments at a time. Which compartment to be heated was randomly changed between the observation days to prevent horses from choosing compartments based on preferred position rather than the presence of additional heat. Horses were trained to enter both compartments in the shelter and were given time to habituate to the paddocks outside the shelter. Individual horses were led by a halter into each compartment and offered a half a kilo of hay. And when horses voluntarily and without being led entered both compartments and ate the hay, the horse was characterized as ready to start the experiment. The number of visits to the shelter before the horse voluntarily entered the compartment varied from 1 to 6. And based on the horse's behavior and confidence in entering the shelter compartments, we tested and repeated the test at least once to make sure the behavior was consistent. Weather conditions were scored using a professional weather station, and direct observations of temperature and wind were also added. Weather was later categorized into 4 categories for analysis as follows. 1. Temperatures above 0 degrees centigrade. 2. Temperatures below 0 degrees. 3. Mild temperatures and rain. 4. Below freezing temperatures and sleet or snow. There was very little wind during this first winter of observations, so we decided to disregard any effect of wind, but we included it in later paper. Each horse was placed for 2 hours in its familiar paddock without blankets, and then the horse was led into the experimental paddock and observed. Observations were performed by a present observer using instantaneous sampling every minute for 1 hour. At each point observation, we recorded horse location, either being outdoors or in a non-heated shelter compartment or in a heated shelter compartment. And at the same time, we scored behaviors from a predefined ethogram of 8 behaviors that we could see horses were doing outdoors. Finally, some results, and I will try and spend a bit more time on this. The effect of weather on use of shelter. Horses spent more time in heated room during cold weather and snow than in any other weather categories. There were, however, large individual differences where we observed one older horse, for example, to almost exclusively seek out the heated compartment and stay there for the rest of the experimental observation. Other horses, however, visited the shelter compartment briefly before they chose to stay outdoors most of the time, and many of the horses were outdoors. There were few effects on behavior. We could see that sniff or eating behavior was significantly affected by weather, but it's difficult to explain why. Muscle shivering was only observed during mild weather and rain, and the same was almost true for the behavior stand tense as well. But this is maybe the most important figure. Small warm-blooded horses used the shelter to a greater extent than small cold-blooded horses. This says something about the effect of breed characteristics and maybe also fur. We also observed the effect of hair coat variations, and horses with a low hair coat sample weight used the shelter more than horses with a large hair coat sample weight. When outdoors, individuals with a low body condition score spent more time standing passively than individuals with a large body condition score. As first hypothesized, we found that weather factors affected the horse's use of a shelter, but we observed large individual differences. And rain did not increase use of shelter, but low temperatures and snow did. The effects of precipitation became clearer after adding data from a second year of observations. And this will be published in my paper. Horses seemed to handle the Arctic winter weather surprisingly well. Even though they were used to wearing blankets, there were very few observations of standing tense behavior and shivering behavior. We found no clear effect of weather on behavior, but the results became stronger after adding data from year number 2. As predicted, we found that small cold-blooded and small warm-blooded houses used the shelter very differently. This is, however, an effect of size and relative body surface to body mass, over which small individuals lose more heat to its environment than large individuals. In addition to this, we observed interesting effects of body condition and coat characteristics on the use of shelter that has never been described previously, to my knowledge. So, to conclude, we should perhaps assess each individual and its body condition and coat characteristics, rather than only look at the breed and common practice to predict the need for additional heat or blankets. To provide a shelter may be a better option than putting blankets on the horse, giving the horse the opportunity to adjust its heat loss to the environment in a much better way as weather changes throughout the day. And I would also like to thank the horse owners, the Swedish-Norwegian Horse Research Fund, and the Norwegian Research Council for funding. And thank you for your attention.